Hello all, welcome back to our Aislyn Technologies YouTube channel. Today we're going to see about secured communication of text and audio using image steganography. First, I will explain our abstract. Our abstract outlines a study of enhancing data security by using image steganography for hiding text and audio messages within images and aim to achieve secure communication. The important points are like data security is for a rapid growth of our data transmitted online has heightened the need for robust security methods. In steganography, a technique for hiding data with within various media types such as images, audio, and video is one of the way to secure sensitive information. And in steganography basics, the goal is to embed hidden data so that only the sender and intended recipient are aware of it. This is accomplished by identifying redundant parts of cover medium, that is, an image, where the data can be modified without noticeable changes in quality. Here, the image as used as cover medium for hiding text and audio message. A symmetric key, that is a single key for both encryption and decryption, is utilized to enhance security, ensure that only authorized parties can access the hidden information, and and the performance can be better than existing technique based on a wavelength transformation, achieving higher PSNR, that is peak signal to noise ratio, and SNR, that is signal to noise ratio values. These symmetric these indicate that the hidden messages does not significantly degrade the image quality. A crucial factor is steganography. Here, I will summarize our introduction. First, unlike cryptography, which scrambles data to make it unreadable, steganography hides the very existing of data. It makes sensitive information undetectable to unauthorized users, even if the data is intercepted. This is a crucial for application needing discrete communication like military and intelligence operation, online transaction, and medical imaging. And then there are two types of steganography. It both can be classified into two categories. Multimedia steganography is used to text like audio, images, and video to hidden data. And linguistic steganography involves hiding information within text using NLP to convey hidden messages. Within multimedia steganography, techniques also divided into irreversible method, reversible method. And the images are often used in steganography because their RGB pixel structure allows the subtle modification, particularly using the LSG method. By changing the least significant bit in the pixel data can be hidden without noticeable visual destruction. Here, a power statement is enhancing the data security in the face of rising internet data transmission. First, the data security challenges. More sensitive data is shared online. The risk of interception and unauthorized access has grown. Conventional cryptographic technique can protect the content by rendering it unreadable, but they do not hide the extensive of a data itself, which may still attract attention. Need of steganography to address this steganography provides a way to not only secure data but also make it unnoticeable by embedding it within common media like images. This method reduces the likelihood of data being identified and targeted. The main key is to develop a method that can be effectively hide both text and audio within a single image without degrading the image visual quality. At the same time, the approach must be ensure that the embedded data retain its integrity and can be retrieved accurately. Here, our objective has a four main objective. First one is high quality and low distortion. Here, it ensures that the embedding data within the image has minimal visual impact. The goal is to maintain high ESNR and SNR values, indicate low distortion in the steganography image, and high fidelity in the extracted data, and then secure transmission. The Stegno key for encoding the embedded text and audio, ensuring that only authorized individuals within the key can access the hidden information, and the enable princess retrieval of hidden data and audio data from the steganography image, minimizing data loss during extraction to ensure the embedded information remains accurate and intact. Co- Compression and validation. The performance against established technique like a wavelet transformation to demonstrate improved security, data integrity, and image quality retention. So this is our problem statement. Here, a proposed system presents a multi-step process for securely embedding and retrieving encrypted text messages with an image using enhanced visionary cipher and LSG, least significant bit steganography. First, our message encryption algorithm works like the process user extended visionary cipher to transform plain text to ciphertext. First, our input will be the plain text, and then process. That's a formula called CE1 CI equal to TI comma KI, and that is nothing but C is nothing but a character of ciphertext, and T is a plain text, and K is a key. Yeah, this is how it works. And then if the key is shortened than the plain text, it repeats to overcome the full message length and ensuring every character is encrypted. And then in message decryption algorithm, the decryption reverses the encryption to retrieve the original plain text. The inputs will be a ciphertext and key, and it uses a formula to reconstruct each character of the plain text from the ciphertext and key. The key repeats to match the ciphertext length as needed, allowing accurately decryption of the entire message. And finally, our data embedding algorithm. This algorithm responds to the embedding of the encrypted message without any cover image. Yeah, and then last but not least, it's a data extraction algorithm. In this algorithm uh, retrieves the hidden message from the signal image by reversing the embedding process. Yeah, this is how it works. Now I'll show you our workflow. Yeah, first we will start the programming by give the any input. Yeah, and then we give it this is our flow chart. First, we will give input, any input like text, voice, and image. After that, we will encrypt our message using our visionary cipher. This is an algorithm. After this, this cipher text it will be into a cover image. After that, there's a last process called our reversing process that will be done before it, and then our output will be saved as output Stegno image will be saved as this. Now run the program, so you'll have a good clear understanding on this. Yeah, this is our main code. I'll run this code now. You can see this. Here's our GUI. First, I'll load our cover image to cover the our data. So we need a cover image. So I'm loading it. So I'll upload this as our cover image. So behind this, our inputs will be covered. Now I'm going to select a type of the input, whether it's a text or audio or image. I will give an text input here. Okay. Now I'm going to read the data of the text input. This is our file, so text document here. Okay. Now you can see this. Our welcome. This is an steganography tester. This is what our message. So encrypt after encrypted, it could become like this only. Now we're gonna cover this image. I'm using steganography. Yeah, our text is covered. You can see this encrypted successfully. Now what I'm going to do is I'm going to extract it. Yeah. After you can see this. You can see this is Stigno. This is what we should run now. Yeah, you can see behind this, the welcome. This is a steganography tester. The message was encrypted. The message was in the data, so that this was encrypted, decrypted here. Yeah. Now I will do for other one. You can see for image I will do. I want to read the data, image data. Yeah. I want to read this. I want to encrypt this. Now I want to do encrypt. Yeah. Here it is encrypted. You can see encrypted successfully. Now I want to decrypt it. You can see our RGB image, which was updated now. You can see the time also. Yeah, you can see this is the image behind the decryption. Yeah, this is how it works. Yeah, I hope you are clear with this project. If you have any doubt regarding this, you can leave a comment in comment section and don't forget to like, share and subscribe. Thank you.